Hello, my name is Sandhuni Chamindi and this is my demonstration for SIT 329 Task 2.0P Introduction to the CMSIS libraries for ARM MCU programming. In this task, I develop a custom GPIO libraries using CMSIS register for the SAMD21G18A microcontroller on the Arduino Nano 33 IoT. Instead of using Arduino GPIO functions such as pin mode, digital write and digital read, I create my own GPIO functions to directly control the GPIO register. My project contains three files: gpio.dkin.h, gpio.dkin.cpp, task 2.0p.ino. The header file contains the GPIO model definitions and function prototypes. The source file contains the implementation of the GPIO functions. The main Arduino is sketched using those functions to blink them on board LED. This is my header file. First, I included Arduino.h, which provides standard Arduino data types such as bool. Next, I created the GPIO mode enumeration, which definition two modes: input mode and output mode. Finally, I declare three functions: config GPIO, write GPIO, read GPIO. Those functions are implemented in the source file. Config GPIO. The first function is config GPIO. This function receives the port, pin number and GPIO mode. It first checks whether the selected port is port A or port B and selects the corresponding GPIO group. If the port is invalid, the function returns false. If the mode is output mode, the function uses the DIR-SCT register to configure the pin as an output. Otherwise, it uses the DIR-CLR register to configure the pin as an input. Finally, the function returns true to indicate successful configuration. Write GPIO. The second function is write GPIO. This function also selects the correct GPIO port. If the required state is high, it writes to the out SCT register. If the required state is low, it writes to the out CLR register. This also the GPIO pin to be switched on and off directly through the CMSIS registers. Read GPIO. The final function is read GPIO. It selects the correct GPIO port and reads the IN register. Using bit mask, it checks the state of the selected GPIO pin. The function returns true if the pin is high and false if the pin is low. In the main program, I first include the GPIO library. Inside the setup function, I configure pin PA17 as an output using my own config GPIO function. Inside the loop function, I call write GPIO to set the pin high, wait 1 second, then send the pin low and wait another second. This repeats continuously, causing the onboard LED to blink. I will now compile the project. As shown in the Arduino IDE, the compile completes successfully without any errors. I will now upload the program to the Arduino Nano 33 IoT board. After uploading, the onboard LED blinks every 1 second. This demonstrates that my custom GPIO library successfully controls the GPIO pin using CMSIS registers instead of the Arduino GPIO functions. In conclusion, I successfully implemented a custom GPIO library with the function config GPIO, write GPIO and read GPIO. Those functions were used to control the onboard LED on the Arduino Nano 33 IoT without using Arduino GPIO functions. Thank you for watching my demonstration.